So hello everyone. Today in this lecture we are going to see a substitution cipher which is very powerful and that time easy as well. And the name of the cipher is Playfair Cipher. So let us begin about what is Playfair Cipher basically. So so a small point-wise introduction says that it is a multi-letter cipher. That means it can take more than one letter at a time, and it can cipher it. Ciphering means you convert a plain text, a normal text, a raw text into a unreadable or a different set of characters, right? In this type of ciphering, we actually use the key as a text message. Okay. Earlier ciphers or the cipher that we will see in next lectures generally consider a key as a matrix or a number, but in this we are considering a key that is used to cipher, change the plain text to ciphertext is a set of word or a string, right? So if I say that, I hope you all understand that plain text, you understand this. Let me see. You understand that plain text P will be converted into a ciphertext C by a use of a key K. Okay, so we are talking about this K, that this K is actually a set of words. Suppose the word is, say, meat. Okay, this is the word. Okay, or the word can be uh, hello. Okay, so this hello or meat can act as a key, and it would convert a plain text into its corresponding ciphertext. This is what actually we mean by the key, that is that we're talking about a word or a string. Now the we will use a matrix format for entering the value of the plain text and the key, and then we have certain set of rules which will convert a plain text to the corresponding ciphertext. We will see one by one what how we draw a matrix and how we populate a matrix. Then we will see how we convert a plain text into the ciphertext. So let us see how we calculate the matrix. So you can see here that we have this matrix here, right? We have this matrix. So this numbers 1 2 3 4 5 that is that we have here, these numbers are the columns, and these set of values are the rows. Okay, so we have 5 rows and 5 columns. So in total we are having a total an amount number of element is called 25. So we can populate 25 elements in this matrix, and as you know, this is a multi-letter cipher. So in English, if we go and talk about English language, there are 26 characters, right? So we have 26 characters. So one of the characters will be the two characters will be occupying a single cell in this matrix, right? And now the thing is, what two characters will be occupying a single cell is not let on the user cannot select it. It is a predefined set of characters, and it has been defined that which characters will come together and which will not be coming together. So we will see one by one how we are going to populate this. Now let us understand that what is the keyword. So if I have a key, say a key by the name called, I have a key with the name called monarchy. I have a key here. I have a key with the keyword called monarchy. Okay, this is the keyword monarchy, and I want to populate this matrix with this word called monarchy. Then how I should populate? I will populate first. I will read each word from this key and populate that word here. Suppose I will populate M, then the next word is O, the next word is N, the next word is A, and the next word is R, then the next word is C, then H, and then Y. Okay, so understand that you will fill the matrix in a row fashion, and if there are a word which is repeating twice, you will only enter it once. Understand? Now the next thing is how what about the other words, other empty cells? So first of all, the matrix will look like this. Okay, now the next cell, that is the fourth cell in the second row and the fourth column, we will start filling it with the characters which were left in the series, alphabetic series. So we have A already. Okay, we already have this A. We already have A, so we won't fill A again. We don't have B, so we'll start with B. Then we already have C, so we will leave C and we will populate D. Then we don't have E, so we have E. Then we don't have F, then we have F. Then we don't have G. Then we have H already present, so I will go for I and J always come together. Okay, then I have a K, I have L, M and O are there, P, Q, R is there, S, T, U, V, W, X, Y is there, and Z. So we populated all these all this particular type of characters that we have in my dictionary, that is in English dictionary. So I have A to Z. I filled all the characters. So I have filled in all this particular matrix with all the characters from A to Z. Okay, the rule says the first of all you need to fill in. You will start filling the matrix with this keyword, and then rest of the key from the A to Z left out words, alphabet should be filled in. So we will have something of this sort. We will fill in and we will get a perfectly 5x5 matrix in which if you see, you will have this I and J that will come together. Always, they will always come together. Okay, they will always come together. So you will always have to put I and J in one cell, whatever is the location. The I and J's location is not fixed, because the keyword might change, this keyword might change, and then this cell will, this I and J will occupy in any other cell. So but I and J will always come together. So if you have filled in this particular matrix, right, now if you understand how we do this, then becomes the rule. Now the second thing is the rules. We will have to study about rules that will change the plain text or PT into the corresponding cipher text. Okay, now we start with the rules. So the rules, number one is, whenever we create a plain text, what we need to do is we need to create a pair of two. Okay, a pair of two. So that means this algorithm is a digraph algorithm, that it actually takes two alphabets one at a time. So rule number one says, if the letters in the pair are same, fill in the filler character, example X, in between the two. So it says that, suppose this is the plain text balloon. So first of all you need to create the pairs. So I create BA, LL, OO and N. Now you say this N is left, now this is single. As of now we are not this rule doesn't talk about anything about a left out character, but we have seen that the first thing is we have two L's together and we have two O together, right? So the rule says that no two characters in a pair can be same. So what we will do, we will fill a particular filler, say X, in between these two. This X might not be a part of this plain text. So what will happen here is, first of all, we will take BA, then we will take the first L and we will have a filler character called X, right? The next thing is, now if I have added an X here, then the next part will be L is left. Now the next L will map to O, and now the next O will map to N. So in that case I have created 1, 2, 3, 4. All four pairs of the characters are now different. Okay, so now this rule actually applies. Okay, this rule is not valid now because I have all the four character pairs with having two alphabets, and in these pairs all two alphabets in one pair is different. Okay, so this is the rule number one. Rule number two says that if I have two characters in a particular plain text that fall into the same row, now how they will be working, like suppose I have N, this is N and this is R. So I have these two in as a plain text. So I have these two as a plain text. So the rule says that then we shift the characters to the right in a circular manner. That means I will change N by A, and R will be changed by M. Okay, R will be changed by M. Okay, so this will, N will be changed by A and R will be changed by M. So the new word will be AM. Okay, so this is about right shift in a circular manner. Now likewise, rule number 3 says that if there are two characters that fall under the same column, now they again have to be shifted in a circular fashion. But this character, suppose M, and this character U, okay, they are the plain text. So M will be shifted by character beneath it. So this is C. So M is shifted to C, right? And U, because this is a character, it doesn't have anything beneath it, so we will have to circulate it in a circular fashion. We will go and change it with the next character, that is M. So we will change this U with M. Okay, so we will change in them in circular fashion. So these are the three rules. Now the fourth rule is certainly a little important. The fourth rule says that suppose you don't have a plain text in the same row or same column. The text that is in the plain text belongs to a different set of rows and different set of column. Then how you proceed? Suppose the plain text was OS. So first of all, let us highlight O, and the order should be maintained, O and then S. Okay, let me put it up. O and S. Okay, so O comes first and S comes afterward. So now what happens, we will have to check the intersection, a cross section of that particular two elements. So let me change the color so that it can be visible now. So the thing is, okay, so if we map this O and we see where these two meet, they meet at A. Okay, likewise when I create a line, the lines intersect from S and O and S, it intersect at P, right? So the next word will be PA, but which word comes first? O comes first, so it will replaced by the same character in the row. So O has what character in that same row? A. Okay, O has the character A in the row and S has character P in the row. P in the row. Okay, P. So the new word will be AP. The new word will be AP. This is the new character. This is the new characters that will be formed. So these are the four rules that need to be understood before we actually go and work with Playfair ciphers. So now if you understand that how we are going to populate a matrix, how we are going to apply these four rules and convert a plain text into a cipher text, let us there's a question for all of you. The question says that you need to actually create a cipher text for a given plain text using the keyword as a key. Okay, so what you need to do is you need to actually create a matrix, right? You need to create a matrix, and the matrix will be of 5 cross 5 dimensions, right? So let me create a matrix for one of the systems. Okay, I will tell you the overview. You all can actually perform the computation, and you can paste the answer in the comments as well. So the keyword is keyword. The first we will fill it, or let me change it. uh, Let me make it red. So this is K is the word, then I have E, then I have Y, then I have W, then I have O, then I have R, then I have D. So all these words are filled, keyword. Now we will start filling the matrix with the initials. Okay, A to Z. So does I have A? No, I don't have. So A, so I will fill it by A. Then I don't have B. Then I will fill it with B. Then I don't have C. I will fill it with C. Then I have D. So I won't fill D. Then I have E. A, B, C, D, E. So let me write it here. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. These are the words. So I have filled in A, I have filled in B, I have filled in C, I have D, I have E. I don't have F here, so I will fill it with F. I don't have G anywhere, so I will fill it with G. I don't have H anywhere, so I will fill it by H. Now I don't have I and J, right? I don't have I and J, so I will fill these two together, right? I mentioned that they always go together, I and J. Then I have K, so I will won't fill K. Then I don't have L, so I will fill in L. Do I have M? No, I don't have M. M. Do you have N? No, I don't have N. I have O. I won't fill O. I don't have P. I don't have Q. I have R, so I won't take R. I don't have S, so I will fill in S. I don't have T, I will fill in T. U, V. I have W, X, and I have Y, and I have Z. So this is the complete matrix that actually this is a complete matrix that will actually be used to compute the answer of this particular set of answers. Like now, if you know this thing, if you understand this particular thing, then let me go ahead with one of the examples. Suppose I'm going to create this. I will take first plain word. So let me erase this particular content. Okay, let me erase this up so that I have space for writing I have space for creating the pairs. So let me put in now. So if I have a condition like this, why don't you, it has some punctuations. We will not use punctuations. So we will first of all write everything in caps: W H Y D O N T Y O U. Now what we do, we will actually create pairs. We will actually create pairs now. So pairs of WH is one pair, YD is another pair, ON is another pair, TY is another pair, and OU is another pair. So we don't have anything in common. So rule number 1 doesn't apply. So we will go to rule number 2 now. We will check from 2 to 3, 2, 3 and 4 how we change. So we will find W here. So W, we find it at this place. This is the word W. Now what is H? We will find it H. We will find H here. Okay. So these two are in different column and different row. So rule says that we will see the intersection of W and H. Okay. So in the rows. So W and H intersect at suppose Y in the first row. So this W will be changed to Y. And H and W intersect I or J. So I can have here either I or J. Okay. Then again Y and D. So I have the new word called Y. This is the Y. The next word is Y. And this must be D. So it's E and A. It's simple, right? So you will get E and you will get A. Then O and N. O is here and N is here, right? So O is E and N is S. O becomes E and N becomes S. Then again you have T and Y. T is in the first column last element and Y is in the first row third element. So Y is the second character. T is the first character. So the word will be W and K. The word will be W and K. And O and U. O and U are in different columns and different rows. So rule number 4 applies and O will change into E and U will change into W. O will change into E and U will change into W. Z. So the cipher text will be Y, I or J, E, A, E, S, W, K, E, Z. So this will be the new cipher text for the corresponding plain text which is mentioned here. Okay. Likewise, you need to create the plain text for the next two of the examples. In some of them you need to fill in the filler characters, and then if you have a word left out, an alphabet which is the last alphabet which is don't have a pair, you can again use a filler to make it a pair. Okay, so that's all for today, and hope to see you in the next video on next algorithm which is called Hill cipher in some days to come. Thank you.